Hello everyone, welcome to Pepcoding. So today we are going to discuss the question vertical order sum of a binary tree. So we'll be given a binary tree and we have to print the sum in vertical order. So for detailed information, let's move to our tree. So the question is like we are given a binary tree and we have to print the vertical order sum. Firstly, to know the vertical order sum, you must be aware of the question how we are going to traverse in vertical order in a binary tree. If we have been given a binary tree, then how we will traverse in our binary tree in vertical order. So for that, you must first watch the video of question traversal in traversing. The question is vertical order traversal. Okay, so question is vertical order traversal in binary tree. Okay, so if you will know this question, then it will be more easy for you to understand and find the sum of that binary tree. Okay, so let's move to our question. So I'm giving a brief intro of the question vertical order traversal, what we used to do in that question. See, if we'll see in this binary tree, then these are the vertical levels. This is the 0th level. This is the 1th level. This is the 2th level. This is the 3th level. This is the 4th level. And this is the 5th level. So vertical levels are 0, 1, 2, 3, 4 and 5. And if we'll see the nodes present in each vertical level, then 0th level has 4, 1th level has 2 and 8, 2th level has 1, 5 and 6. So 1, 5 and 6. 3th level has 3, 4th level has 7, 5th level has 13. So this is the vertical order traversal of binary tree. Okay, and if we have to find the sum out of it, then what will be our answer? 0th level will have sum 4, 1th level will have sum 2 plus 8, that is 10, 2th level will have the answer 6 plus 6, 12, 3rd level will have 3, 4th level will have 7 and 5th level will have sum 13. So we have to find the vertical order sum. So our answer will contain these values. Okay. So this is all about the question, and now we'll talk about the solution, how we will attain this thing. Okay, so this is 0th level, 1th level, 2th level, 3th level, 4th level and 5th level. See, in this question we'll also take help from one more question. Firstly, vertical order traversal, and the second will be width of a binary tree. How this, see, if you haven't seen the videos of these two questions, then first go and watch these two questions. It will be more easy for you to understand this particular question very well. Okay, so these are the separate questions, you must watch these questions first. Okay, so how width of a binary tree will give us? See, if we'll see in this particular binary tree, then width of this binary tree is how much? 6. How? 1. See, it has 5 vertical levels, and if we'll see the width of it, then width will be 6. How will you find width? See, if we are given a range of 0 to 5 and we need to find the width, then how we'll find? We'll find by 5 minus 0 plus 1. Okay, this is how we'll find the width. So what this width function basically do, this width function give us a range from minimum range to maximum range. Suppose we are at this 0th position. Okay, we are at 0th position. So our next position will be -1, then next will be -2. From right side, it will be 1, it will be 2, it will be 3. So what width of a binary tree will do? This will give us the range from -2 to 3. Okay, so this -2 and 3, this range we'll use to find the width. How? 3 minus -2 plus 1. So this will give the width. Okay, so what is the use of this width? See, if the width is 6, then it means we have 6 vertical traversals. 6 vertical traversals. So we need to create an array list of size 6. Okay, so let us create an array list. One, 2, 3, 4, 5, and 6. The size of our array list is 6. Okay, so now we are discussing the solution approach of it. So what we'll basically do, we'll implement a queue. What we'll add in our queue? We will add a pair in our queue. How? Let me erase. So this is our queue, and this is our array list. Okay, so we will maintain our sum values in our array list and using the queue. What we'll do in our queue? See, if we have found the range, then we have found the width also. And see, the range is also in negative. This is -2, this is -1, this is 0, this is 1, 2, and 3. So to make it positive, what we'll do? We'll add this minimum value. We'll add this minimum value in each level. So +2, +2, +2, +2, +2, and +2. Okay, so this will become 0, 1, 2, 3, 4, and 5. Okay, so why we are doing this, you will get to know soon. Okay, so firstly we will have access to our root, and indexing we have done like this: 0, 1, 2, 3, 4, 5. So how we will get access to it? See, we will pass the root value in our function, and we'll add this root value in our queue along with its vertical level. So its vertical level is 2. So we'll add its level Now what we'll do, if we have added the root value, then the size of q is 1. Okay, right now size of q is 1. So now what we'll do, after adding into our q, we will remove it. See, we'll remove it from q and we'll add it to our array list of particular index. So our root value is 0 and its indexing is 2. So we will add this 0 at 2th index of our array list. Initially array list is containing zeros all in all the indexes. Now what will happen? We'll add this 0 in the index 2. So we'll add this 0 and the size will become 0. So now what we'll do, as soon as we are removing the node, we'll also add its left and right children in our queue. So left and right children of 0 are, okay, so the value of root is 1. So it's the mistake. So value of root is 1 and I have written 0 over here. So value of root is 1. So 1 will get added. Okay, so now we'll add children of 1 in our queue. Children of 1 are 2 and 3. Firstly, we will add left children and its index is 1. Means to say is its vertical level is 1, its vertical level is 0, its vertical level is 1, its vertical level is 0, its vertical level is 2, its vertical level is 3, it's 4, it's 5. So while we are adding its children, left and right children, we'll also add its right children 3, whose vertical level is 3. Now the size of q is 2. Now we will access these nodes 2 times. So firstly, we'll access left child. So what we'll do, we'll remove left child, we'll add its value in index 1. So index 1, this is indexing and this is the node value. So we'll add 2 at 1th index of array list, and also we'll add its left and right children. So 2 is having left and right children as 4 and 5. So we will add 4 with its index, which is 0th level. Okay, also its right child is 5 with its level, which is 2. Okay, now what we'll do, we will decrease the size. Now the size is 1. Next we will access to this node. We'll remove 3 and we'll add at index 3 and we'll add its children. So 3 is having children 6 and 7. Firstly left children, then right children. Level of 6 is 2. Level of 7 is 4. Okay, so now the size, now this size will get decreased. This is 0 and this size is 4. Okay, so now it's the turn for 4. We'll remove 4, we'll add 4 at 0th index, and also we will add its children. So 4 is having children, left children is nothing, right children is 8, and the level of 8 is 1. So now its size will get decreased to 3. Now we will remove 5 and we'll add at index 2 and we'll add its children. So 5 is having children, 5 is having no children, so we will just reduce the size. So now we'll remove 6 and we'll add 6 at index 2 And also we'll add children of 6. 6 is having no children, so just reduce the size. Okay, now we will remove 7 and we'll add at index 4. And also we'll add its children. 7 is having no left children, only right children, so 13 will be the right children. So now 13, level of 13 is 5th. Now the size will get decreased, and now the size of Q is 2. Okay, so now we will get access to this 8. We'll remove 8 and we will add this 8 at index 1. And we will add its children. 8 is having no children, so just decrease the size. And now we'll get access to 13. We'll add 13 at index 5 and we will add its children, but 13 is having no children. Just reduce the size. Now the size of Q is 0. So now we have to do nothing. We have just stored our answer. So this is array list which is containing our answer. And if we'll see level order wise, then 0 will have the value at 0th position. This is 0th position, we'll have the value 4, and at 1st position we'll have the value 10. At 2nd position we'll have the value 8. At this position 3, 7 and 13. So we have learned about the approach to solve this question. Now we will implement our approach in our code. So let's move to our code section. So we'll be working on this function vertical order sum. And our very first step is to find the width of tree. Okay, so we have created a function width and we'll pass root and its horizontal level, and we'll create a array of min max which will store the range. Okay, so this will done. So min max of size 2, because we need only the minimum range and maximum range, so of size 2. So this function will give us the width of the binary tree, range of the binary tree. Okay, so now we will find length out of the range. So minimum range, maximum range minus minimum range. So min max of 0 will contain the minimum range. So min max of 0 plus 1. So this will give us the length. And using this length, we'll create our array list and we'll declare the size of array list as length. So we should also make the function width See, I am not going in detail of this function width, because as I have told you, this question is a separate question. For detailed explanation, you can visit that question. So here I am just creating the function to find the width. And next, what at horizontal level? So what we'll check first? We'll first check if root equals to null, then simply return. This is our base condition. So then will maintain answer of 0, and this answer of 0 will contain minimum range. So mat.min of horizontal level and answer of 0. Answer of 0. And same thing we will do for finding the maximum range. And we'll store this in answer of 1. This will be max function and this will be answer of 1. Okay, and now we'll make left call and right call. So width root dot left, decreasing the horizontal level, and answer. Same we'll do for the left call, sorry, right call. This we have done for the left part, and this we are doing for the right call. Horizontal level plus 1. So this is our function for finding width of binary tree. If you are not getting the what we are doing in our HL and from where this HL came, so this is the horizontal level. This will contain the horizontal level indexing. So initially it is passed as 0, and as I've told you, for detail you must visit the width question of width, finding the width of binary tree. So we are back in our function. Now we'll proceed further. So now we will create a array list of answer of size length, array list of integer, new array list, so we will initialize our answer with 0, all indexes. So this is how we have initialized. Now our next part is to create a queue. See, till now what we have done, we have our range, we have our length, and we have created, we are now on what next, and we have created our answer array list. Okay, so side by side I'm writing over here. So till now we have this range -2, 3, we have this length as 6, and we have created a array list of size 6. So 0, 1, 2, 3, 4, 5. So this is array list, and now what we are going to do, now we are going to work for creating queue, and this queue will contain a pair of root and indexing, that is this level. So level and root. So we will also create a pair class, and we will add this pair in our queue. So let's work for it. So linked list of pair, vertical pair, and this will create a class for vertical pair, class of vertical pair. Okay. Okay. So now what we'll do, we'll add the root value along with its level in our Q. So firstly we'll add. See, we are doing add last. If when we were discussing the solution approach, then we are inserting at the last and was deleting from the starting. Okay, inserting at the last and deleting from the starting. So same thing, we'll add at last. We'll add this pair of what? Of root and level. So we will have the positive value of it. That way mat.abs and min max of 0. Okay. So till now we have created our queue and we have added our very first root along with its level. So what we need to do now, we need to create pair class, that is vpair. So class of vpair. This will contain node and horizontal level. Horizontal level. Okay. So our class is ready. Our vpair vertical pair class is ready. Okay. So now what we'll do, so we'll start our while loop till size of q is greater than 0, and also we'll create another loop for size and we'll decrement size each time and check whether it is greater than 0 or not. See, if you are not getting this thing, then I'll be explaining it right now. Q dot size greater than 0. I hope now it is visible properly. So what we have done here, we have created a while loop of q dot size greater than 0 and we are iterating till the size is greater than 0. So basically what this is doing, see, we have added the size of q and we were accessing each element, means we were accessing each node. See, the size of, initially we have created the loop while loop for size, and for every node we were iterating. So there is a loop inside the loop. So now what we'll do, we will remove the very first element, means we are removing from the first, we were adding, sorry, we are removing from the very first of the queue. So removed pair from remove first. And what we'll do now, we will store this removed pair safely, because from this removed pair we are going to do a lot of things. From this removed pair we were also adding this into the array list and also making call to its left and right children, so we have kept it safely. we have stored in the node. Remove pair dot node. Our horizontal level will be remove pair dot horizontal level, and we'll add this into our answer. So we have created the array list of answer, and now we will store this in our answer. So answer dot set, what this set will do, this set will add the node value at the specified index. So our index is HL, and at this particular index we will add the value. Node dot value. See, our work is not to only add the value but also to maintain the previous stored value also. We are adding one by one. At a particular index we are adding all the possible nodes. So now we will make call to, now we'll check its left and right children. If left and right children are present, then we will add that left and child children in our queue. Okay, so we'll check if left is not equals to null, then we will add this in our queue, and we'll be adding at last. So node dot left, and we'll decrement the level. So this will be node v pair, and same thing we'll do for the right child also. So just copy paste it. So we'll check the right child. Node dot right will increment the horizontal level. Okay. So after doing all these things, we'll return our answer. Okay. So we have discussed almost everything. Whatever we are doing in our code, line by line. See, we have declared an array of min max for storing the range, and we have found the width. We have called the width function, also created the width function, and we out of that min and max array we have found the length, and using that length we will create our answer array list and to store the sum values. Firstly, we will initialize every index with 0. Okay, then we have created our pair for we have created the queue, and that queue will store the v pair, means vertical pairs, and we have added the very first node, that is root node, with its level. So now then again we are iterating in queue dot size, and we are removing the node from the, see, we were removing the node from the queue, and we have stored this removed pair safely. Why? Because we need to do a lot of things. What things? We will add its value into our answer array list, and also we will make call to its left and right children. If they are present, then we'll add its children in the queue also, and after doing all these things we'll return the answer. So let us run our code. So there is some error. Okay, so q dot size greater than the 49 line number. Okay, so at last there is return null 41 line number. So there are 3 errors. Okay, so I less than length. Okay, I less than length. So this we are returning array list integer. Okay, so we have created array list of answer, and here I have written answer of I, which is the correct incorrect format. So this will be answer dot add, and we are adding 0. So I hope our now code is correct. So okay, let us submit it. So all the test cases are passed. So I hope you have understood the problem and the solution also. So thank you for watching. We will be meeting in another video with another question.